Hello students, welcome to the video on image sensing and acquisition. This topic explains us how the image is acquired or how the image is captured. It consists of two things, image sensing and acquisition. Okay, see here this simple slide. This is the energy source, sunlight. When the sunlight energy is illuminated onto the object, this is the object, tree is the object. Some of the light gets absorbed, some gets reflected, and that reflected energy is received by the sensor. See, this green color part of the object is reflecting green light and this pink color is reflecting the pink light. And now this image sensor receives this reflected energy and it will prepare the image. This is a simple slide. In detail I'll explain. See, the images are generated by the combination of an illumination source and the reflection or absorption of energy from that source by the element of the scene being imaged. Okay? So this means the images are generated by the two concepts called illumination and the reflection or absorption of energy. See, to generate an image, you have to illuminate that object using an illuminating energy, and then the object will absorb some amount of energy and then the remaining amount of energy gets reflected. Okay, with that reflected energy only you can generate the image. As I told, it consists of two things, image sensing and image acquisition. What is image sensing? It involves capturing light from a real world scene using a lens and an image sensor that converts it into electrical signal. Okay? Yes, then image acquisition. In this process, the analog signal that gets generated from this image sensing is converted into digital by using analog to digital converter. Okay? If you see the simple figure, this is scene being imaged and this is the lens. So the reflected energy from this scene collected by the lens and it will send that reflected energy onto the image sensor. It will convert reflected energy into analog electrical signal and this A to D converter will convert that analog signal into digital and then that digital signal gets converted into digital image. This is the simple diagram which shows completely the image sensing and acquisition. Now in detail. Okay, to write as an answer for image sensing and acquisition, this is the example. See, it consists of, yes, totally 5 things for image sensing and acquisition. First, we'll see the illumination energy source. What is this illumination energy source? This is the initial step for image acquisition. Okay, from this source, light energy gets illuminated on the scene. This source may be a sunlight or X-ray or ultraviolet rays, etc. Okay. This illuminated energy gets interacted with the scene being imaged. Scene means consisting of many objects. Okay. This scene absorbs some amount of energy illuminated by the illuminating source. The remaining amount of energy gets reflected. Okay, that reflected energy is the base to form the image. Okay, another point is the nature of this illumination source and the direction of this illumination source affects the scene being captured. Okay, now coming to the next one. This is the scene element. See this is a scene element. This is the object that we're going to capture and this scene absorbs some amount of light and reflects the remaining. Okay. And the next is imaging system. This is the imaging system. Yes. This system may be a camera or scanner or sensor. It receives the reflected light emitted by the scene or reflected by the scene. It converts that energy into an analog signal or directly digital signal. This imaging system projects that scene onto an image plane. This is the image plane, internal image plane, which is a light sensitive surface like CCD or CMOS sensor. CCD, charge coupling device, CMOS, complementary mass material. Okay. Then Coming to the internal image plane, actually if you see this internal image plane, you are observing an analog image exactly equal to the scene being viewed. Okay, but this image after the sampling and quantization is converted into digital image. So this is the digital image. Then we'll go for the final thing, that is output digitized image. This is the final output, which consists of pixels arranged in the form of grids. See this? All this is the grid structure. Each pixel carries intensity values based on how much energy it's received. Now you can store this image or process this image or transmit this image because it's a digital image. But the quality of this digital image depends on two things. One is resolution, another one is quantization. What is meant by resolution? Resolution is simply number of pixels. Okay, suppose if you express an image like this, 120 by 120. What is the meaning? This is the resolution. 120 by 120 is the resolution. And the number of pixels in that image is 120 into 120. Okay, the quality of the image depends on the number of pixels, and each pixel is having some intensity values. Okay, so the quality of the image not only depends on the resolution, it also depends on the quantization levels, nothing but number of intensity values per pixel. Okay, so this is about an example of digital image sensing and acquisition. Okay, yes, this is about the types of image sensors. The main part in this is this imaging system. Okay, this imaging system consists of sensors. Now we'll see about the sensors. If you see the single sensor, yes, it receives the energy reflected by the scene or reflected by the object. Okay, what type of energy it is? It is the light energy. Okay, yes. Now this light energy gets sensed by the sensing material after the filter. This filter is used to get your required color, required type of light. Suppose if you want to get a green light, it filters, means it filter in only green light and it stops all other lights. The sensor will convert this light energy into output voltage. Means this sensor is converting light energy into electrical energy. What is the example which converts the light energy into electrical energy? Is nothing but photodiode. Means the sensing material, okay, is like a semiconductor. Okay, some type of semiconductors will convert light energy into electrical energy. Okay, this is about single sensor. To operate this total sensor, yes, we need to give power. Okay, and to protect it, you need some housing. Then line sensor. All these single sensors are arranged in the form of line. Then is array sensor. All these single sensors are arranged in the form of array. Two-dimensional array. Now this is the image acquisition using a single sensor. Okay, see here, this is the drum. Fine. Yes, this is the strip. See this? This is our single sensor. Now the concept is to generate a 2D image. You have to keep this arrangement before the object. Now whenever the object reflects the light, then this sensor will move along the strip. Means the sensor is moving in one direction and the drum is moving in this direction. The single sensor is moving along the strip, means it is moving along X direction, and with this drum rotation, yes, you are getting movement in other direction. Okay, yes, this is X direction and this is Y direction. So this will continue until this total film gets scanned. Now this is image acquisition using a linear sensor strip. See this is a linear sensor strip. Yes, means it consists of sensors arranged in the form of line. What is happening to this? Here it consists of only one single sensor. Okay, this sensor has to move here and here along this strip. But here this line sensor consists of the sensors arranged in the form of line. So already one direction is over. Okay. Then this line has to move like this line has to move like this and this. So what is happening is there exists movement in other direction, so you will get a 2D image. Okay, then this is image acquisition using a circular sensor strip. Okay, this is what happening for the case of CT images, MRI images. So this is the object, it is a patient. Now the object is moving in one direction, this is a linear motion, and this is the circular strip. Yes, here are your sensors, here are the sensors. Sensors are arranged in the form of circular loop. So whenever this object is moving, this circle is also moving. Circle means you are getting movement in two directions. Another direction is this object direction. So with this arrangement, you are going to get 3D objects. Okay. So this is about the image acquisition using single sensor, linear sensor and circular sensor. Okay. Then this is a small topic, a simple image formation model. You know the image is a two-dimensional function f of x comma y. And the amplitude of f of x comma y is nothing but intensity. And the image is characterized by two things. As I said, light must be illuminated onto the object, and then the light gets reflected from the object. There must be two things on the same object. Okay, that is the reason f of x comma y, the image, is characterized by two components, illumination and reflectance. What is illumination? The amount of source illumination incident on the scene being viewed. Okay. The range of illumination is between 0 and infinite because illumination is generally by a light source which we can't measure. And the reflectance. Reflectance means the amount of illumination reflected by the object in the scene. The range is 0 to 1. 0 represents no reflectance, means it is totally absorbed, the light is totally absorbed, and 1 means total reflectance. Okay. So totally your f of x comma y is the product of I of x comma y into R of x comma y. I of x comma y illumination depends on the source and the reflectance depends on the characteristics of the object. Now coming to the grayscale. What is the meaning of grayscale? Suppose x0, y0 is a pixel. Let it be a pixel. The intensity is represented by the amplitude of the function f and let it be L. L lies in the range L minimum and L maximum. When will you get minimum intensity level? When the illumination is minimum, you'll get reflection minimum. Then you'll get intensity minimum. When you get L max, if the illumination is max, reflectance will be max. So you'll get maximum intensity. Okay, so totally the interval L minimum and L maximum is called the grayscale. Okay, you know in the grayscale image you have 256 intensity levels. Okay, in those 0 represents black and 255 represents white. Okay, same way here L is equal to 0 is considered black and L is equal to L minus 1 is considered white on the grayscale. The intermediate levels 0 to L minus 1 are nothing but some gray levels. This is about grayscale or intensity scale. It is defined only for, remember, only for grayscale. Okay, grayscale image. These are just for an example given 3 types of images. See this, the first one is black and white Lena image, and this is the gray level image, and this is the color image. See the differences. See, we can't convert a black and white image into gray level or gray level image into color image. But we can convert a color image into gray level or gray level image into black and white. Yes, we know we can't see a color movie in a black and white TV, but we can see a black and white movie in a color TV. Okay, so that is the thing. Okay, this completes the concept of image sensing and acquisition along with the simple image formation model. Okay, thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.